In this section, we're going to be learning about quadratic functions. And by definition, a quadratic function is anything that can be written in the form of f of x equal ax squared plus bx plus c. The main thing that defines a quadratic function is the fact that it's to the second power. Now we're going to be looking at doing some of the graphs, and all of your quadratic functions are referred to as the shape of a parabola. We're going to look at parabolas that open up, as this first one does, and also look at parabolas that open down. Now I've identified some parts here of your parabola. You'll notice, of course, with both of these, the dotted vertical line that I have in here, that's referred to as your axis of symmetry. And all that means is the left side and the right side of your parabola will be mirror images with respect to that line. So that's called your axis of symmetry, and it is always vertical. You also have a vertex, as in this case I've referred to as the vertex being a minimum point, but that's because it's the lowest point on the whole graph. Whereas this other one, I've referred to it as being a maximum point because it is the highest point on your whole graph. And a little bit further into the lesson, you're going to be asked about finding a max or a min value, and that's simply just the y-coordinate of your vertex. Now, of course, if you're asked for your whole vertex, or you're asked for a minimum point or a maximum point, that includes your x and your y value both. But if it's a max or a min value, then it's just simply referring to the y-coordinate of the vertex. Alright, what we're going to do first is look at your parabolas that are in the form of ax squared plus bx plus c, which is the form that I referred to a while ago. There is another form that we'll talk about in just a little bit. So here are some notes, some characteristics of your parabola that you need to be aware of. You'll notice that this statement, the first statement, refers to a being greater than 0 or a being less than 0, so that's in reference to the coefficient of your x squared. So if this value is positive, it's greater than 0, then that means your parabola will open up, as you saw one just a few minutes ago. If your a value is less than 0 or negative, then that will tell you that your parabola is going to open down. To find the vertex when it's in this particular form, there's a little formula, x equal negative b divided by 2a, and that's going to give you your x coordinate of your vertex. Once you have that value, then all that you have to do is take your x value and substitute it back into the function, and that'll find your y value, the y coordinate of your vertex. We're also going to find x and y intercepts, which is something you've done many times before. To find an x-intercept, then you substitute 0 in for y, which means you're going to end up setting the function equal to y and solving it. To find a y-intercept, then you're going to substitute 0 into the function for x. And then the axis of symmetry, you're going to be asked to identify it. Now, as I said, it's always a vertical line, so that's why here I have x equal. But it's always, the number that it's equal to is always the x-coordinate of the vertex. If you look back at the two that I had sketched off just a minute ago, let them back up here, you'll notice that your vertex always, or your axis of symmetry always goes through your vertex each time. So once you find your vertex, you'll actually know the location of your axis of symmetry. Right now, I referred to there being another form a while ago, and that's what we have here, a couple of notes on this. This particular textbook refers to this form as standard form. Actually, the form we were looking at just a few minutes ago, some textbooks refer to that as standard form, but we'll go with what this textbook uses. So this is your standard form. Now this would also be the way that you would see it if you were asked to graph it using your transformation rules. You see where this would be like a stretch or a shrink. this is left or right, this is up or down, and then you could have your negative sign, of course, to indicate any type of reflection. But we're going to look at graphing it other ways besides just by using transformation rules. So the note there that I made in the middle with the asterisk, it says the only thing different from the other form that we were looking at is the vertex. How you find everything else is exactly the same way. It's just how you have to go about finding your vertex. Finding your vertex in this form is a whole lot easier. It's just as simple as looking at the problem. That's going to be the H and the K. So H is going to be the value that you have either added or subtracted here inside the parentheses. K is going to be the value that's added or subtracted at the end of your function. Now, you notice I said change the sign of H. That's because you notice this is standardly written with a minus. So if this actually says, say x minus 3, normally you would say, well, that number's negative 3. But when you identify it down here as part of your vertex, then you would have to call it positive 3. So write the reverse. If this were x plus 5, and you have a positive 5, then down here you would refer to it as a negative 5. Now that's only going to apply to just the H. You don't change the sign of the K, and that's because you do have a plus sign in front of the K. Is why you don't have to do that. Alright, so getting started with a couple of examples here. All we're going to do first of all is just find the vertex. So for this particular problem, now this is the problem or the form that we just finished talking about that's referred to as standard form. Some textbooks actually call it vertex form because it's so easy to identify your vertex. So this is where we can just look at it. This is the H and the K situation I just discussed. So this is where your H comes from. This is where your K comes from. But you have to change the sign of H. So here I have a positive 4. Therefore here I would use a negative 4. And with your K, you identify it or use it just as it is. So the minus in front of the 7 would mean that you have a negative 7. So that's all there is to finding a vertex when it's in this particular form. Alright, now looking at the other form that we looked at first, this is where we have to use the formula. Okay, so your formula was x equal negative b divided by 2a. So for this particular problem, this is your a and this is your b. So substituting those values in, I would have negative 8 divided by 2 times negative 2. Of course, that's negative 8 divided by negative 4, which reduces to be positive 2. So that gives you your x coordinate. Alright, so now we need to find our y coordinate, which I had given you the notes on, which was to just substitute the value back into the problem. So the 2 that I just found, I'm substituting in. And then now just calculate what we have here. So let's see, that's going to give us positive 7. So that would mean that my vertex is located at the point 2, 7. Alright, so let me show you how you could actually check this on your calculator. And you could do this with the other problem also. So it's no different in how you check it with your calculator when you've got different forms. But first of all, what you would want to do is type the problem in your y equals. Okay, I'm just going to go to my standard window. Okay, now your vertex, of course, depending on which way your parabola opens, your vertex could be located at the top or the bottom. In this case, it's located at the top. So that would be referred to as a maximum point. So you could go to second trace, and you'll notice that option number 4 is maximum. So if your parabola opens up, then you're going to choose option number 3, which would be minimum. So maximum. Now, it always starts out with left bound, so you do need to have your cursor on the left side. Like I would refer to this as being a heel. So you need to have your cursor on the left side of the hill, hit enter, move your cursor around to the right side. You'll notice now your calculator says right bound, enter, and then guess, just move it up to the top about where we think it would be at. Now, some calculators will come out and give you the 2 as we found, but it's not uncommon sometimes, you know, like in this case you have 1.999999, so if that type of thing happens, you know, then you do have it correct, so don't worry about that.